Hello, we'll still wait for a few minutes for others to join. Okay, we can begin. In the last session, we have seen exceptions, custom exceptions. Anybody having any question in how to handle custom exceptions? How to create custom exceptions? Okay, how to create custom exceptions? What is the use of throws and throw in that? And how to catch those by using try and catch. You can also use finally, of course. That is totally your choice. Anybody having any questions in the exception handling keywords? Okay. Okay, fine. Then I wanted to start a new topic today. Before we start that the topic is multi-threading itself. So I wanted to know, what do you know about threads, processes? What do you know about these things? Multi-threading, multitasking, multiprocessing. I want to know, what do you know about threads, process, and everything? Can you tell me what is a thread, what is a process, difference between both of them, anything? You might have done in this operating system. Have you had the sessions of OS in the previous semesters, or maybe in this semester you might be having OS? Okay, good. Then Yes, yes, but you must be knowing then what is a process, what is a thread. Can you tell me what do you mean by a thread? Is a program in execution. Okay, yes, good. The program that you want to execute, and thread is a part of the process, subset of the process. Yes, good, good, yes. Sub process is known as a thread. Yes, you are right. And and what do you mean by multitasking and multi-threading? Have you heard these terms? Yes, what do you mean by presence of more than one program in the main memory? Okay. Yes, you are right. Yes, 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 you are right. Multitasking means presence of more than one program in the main memory. Okay, yes, good. What about multi-threading? Have you heard this term multi-threading? Multiple threads simultaneously. Yes, you are right, Rishabh. It is the ability of the system to execute multiple threads simultaneously. Okay, yes. So multitasking, if multitasking is nothing but you are executing multiple tasks at the same time, you are executing multiple. Yes, executing more than one thread is, yes, you are right, is multi-threading. Good. Yes, yes, yes. So thread is nothing but a sub process, right? So can you give me a real life example of thread or where they are used? Where threads are used in real life. Big programs into smaller parts for faster execution. Yes, you are right. If I give you the example of server itself, the server that you are passing or you are requesting the data from, like Google server. Okay, if you are searching something in Google, then is the Google server itself going to respond to you, or it will create multiple threads for multiple people they are accessing this data, right? The server is going to respond to you on its own, or will it create multiple threads for responding? Yes, exactly, right. So each, yes, exactly, yes, you are right. So whenever you are searching something in Google, the server is going to not respond you only. It is going to create different threads which can give response to different clients. And each of the thread is going to store the IP, and the thread knows that I have to respond to this client only. Okay. Now, whenever you are searching something in Google, you will always wait. You might want to, whenever you are browsing something or whenever you are searching something, say for example, you are searching Marwad University here. Okay. Then you are you have searched it. The thread has replied to you. Now you are ideal on the page, right? Then is the thread active whenever you are ideal on the page? If you are not doing anything on the page and you open this page and you went for a walk, is the thread active at that time when you are ideal? Or the thread also goes into the ideal state or the sleeping state, you can say. Right? Are you getting my point? What I am trying to convey here? Thread is itself having different states. Whenever you are searching the request in Google, the server of the Google creates one thread for you. That is the initial state or the starting state, or you can say the born of the thread. Okay. Now, whenever the whenever the thread is responding to you, it is in the running state. Running state meaning the thread is currently running for you and it is responding to something. Okay, it is giving answers to you. It is nothing but running state. Once the running state is over, or maybe when you are sitting ideally, or you have searched everything and now you just went for a walk, or you just you just going for breakfast or something, then that as long as you are not active, the thread will go in the sleep state. Sleeping state means the thread is in an ideal position. It is not doing anything right now. It is waiting for you to do something. At that time, the thread is in the pause state or the sleeping state or the ideal state. But again, when you start searching something, no, again it is going to show you the list of data over here. So it is again going back to running state. Thread is running when it is responding to you, or when the process is going on. No, the thread is in the running state. But when you want the thread to sit just sleep for some time, it is not working anything. It is sleeping. It is ideal. It is the sleeping state. From sleeping state, it can always wake up when you notify the thread, that no, you have to do this work. Come on, do this one. Show it to me. Show the results to me. Then it is coming back to the running state. Are you getting what I am trying to convey here? Thread, just like process itself, just like you might have heard that processes are having their own life cycle, right? The same way, threads are also having their own life cycle. Okay. Whenever, I'll give you one more example apart from the server itself. Say, for example, you want to watch a movie or you want to play a song. Okay. Then you will be clicking on the application that is playing the song for you. Or say, for example, you are clicking on the VLC media player. Whenever you are clicking on the VLC media player, when a thread is spawned, one thread is created. Why? Because you are opening this player for playing a song, right? So the process at that time creates one thread and it calls the start function for starting the thread. The start function, these are the functions in programming which are going to use it. Start function is the function that creates a thread. Once the thread is born, it goes into runnable state. Runnable means it is able to run. But is it running right now? No. It is runnable means it is ready for running. Whenever you are opening the player, whenever it is in the opening process, or whenever it is getting ready for when you upload the song, or when you add the song in the list, it is getting ready, it is setting the environment for you. It is in the runnable state, it is getting ready to run. So thread can go from start state or born state or new state to runnable when it is ready for run. Once it is ready for run, it is calling the run method to run the thread or to do the execution or to play the song in our case. Okay. Whenever you are loading the song, it is in the runnable state. It is waiting for you to add the songs. From that point onwards, it goes into run state. Whenever it is currently playing the song, it is nothing but known as running state. It is currently playing the song. From running, it may go into waiting state. From running, what all can happen? It may go into waiting state. In waiting state, why it is waiting? Maybe it is waiting for you to start something. Maybe it is waiting for you to add a new song. Maybe it is waiting for you to play the song when you have paused it before. Whenever you are pausing it, it is going into the sleep state. Sleep is again a function. Again, wait is a function. Okay, here wait is again a function for you. Sleep is again a function. Run is function. Start is function. Okay, these all are predefined functions in your thread class in Java. You are going to use these functions in your program, but I'm explaining you the theoretical point of view, what is happening. Whenever it is in the running state, from running state, it can go to sleep whenever you are pausing the song or whenever the song is finished and now it is waiting for you to add a new song. It is not doing anything. It is ideal. It has gone into sleep mode. Or maybe it is waiting for you to press a button to play a song. Then it is in the waiting state. You have paused it. Now you want to play it. When it is waiting for you to press a button, or maybe it is waiting for you to load a song, it is waiting for your next instructions, or maybe it is waiting for some input or output operation to happen, then it is in the waiting state. When you are calling the sleep function, you are manually suspending the thread for some time. You are manually stopping the operation for some time, but whenever the thread is waiting for some input from like for example, whenever you will be reading the files, okay, it is waiting for the file to open in the backend. For reading the file, no, it is waiting for the file to open in the backend. Once it is opening, no, then it can go back to running. But it is waiting for the file to open. That point, it is waiting for some input to happen. Then it is again in the waiting state. Then when it starts reading, no, it comes back to the running state. Okay. And whenever your task is done, whenever your task is finished, whenever your song is played, and whenever you terminate the application, whenever your complete process is done, then it is going into the dead state, dead or terminated state. The last state from which the thread is totally destroyed. And later on, if you want to again open the application, again it creates a new thread for you. Right? Or in another example, whenever you are searching something, you are closing that current tab, no? When you are closing the window or current tab, the connection from your server is lost at that time. It is in the dead state. Right? Yes, are you getting these different states of the thread here? Yes, anybody having any question in these states? Question in what is runnable, running, waiting, sleep, dead, start. These are the 7 different states of a thread. Anybody is having any question in the states of the thread? Yes, anybody having any question in the states of the thread? These states. What is start? What is running? You may be asked in the examination also. In the interview also, they can ask you. Differentiate between running and run state. Running and runnable. Differentiate between sleep and waiting. What is the sleep state of a thread? These are OS level questions. They can ask you in OS also. Okay, that tell me what is the difference between running and runnable. Then you must be able to answer these questions. Anybody having any questions so far? Okay, then you are right about this multitasking and multi-threading. Multitasking means when you are creating for whatever task that you perform, no, you are actually creating multiple threads for that. It is known as multi-threading. So multitasking is in real life applications. Multitasking means you yourself can multitask, right? You can go in the session, you can read a book at the same time, you can even have breakfast at the same time, or maybe you are even chatting with your friends at the same time. You can perform multiple tasks. A person can definitely perform multiple tasks. Same way, even here also in your devices, at the same time, you can listen to a song and you can create a report, or you can at the same time you can write your Java programs, right? That is nothing but system is multitasking for you. You are listening to a song, one application, at the same time you are creating an MS Word document for putting up the programs. You are formatting the document, right? At the same time you are searching the same topic in the Google. It is nothing but multitasking. Even these days you have pieces that can allow you multitasking efficiently. Okay, not slowly, but it can allow you efficiently. Whenever you are multitasking, what is multi-threading? Whenever the ability of multitasking comes in the perspective of application, meaning application can multitask or not, meaning application can assess single software or single process, can create multitasking there or not, can it create multiple threads or not, can it divide the process into different parts or not. That is known as multi-threading. You are handling multiple requests at the same time for one process. That is nothing but multi-threading. Okay. Anybody is having any question in what is multitasking, multi-threading? These are good terms. Anybody having any question in these terms? These terms are definitely exam point of view, theoretical point of view. These questions will be asked. What is multiprocessing, multi-threading, multiprocessing, and multitasking? These three are different things. Huh? Can you tell me what is multiprocessing? Multiple processors in the system. Yes, you are right. If you have one core or if you have one processor, then it is a unique processor or a single processor. But if you have multiple processors that can share the complete, systems memory, they are always sharing, right? Even if you have heard quad core processor, octa core processors, when you are going to buy a laptop, no, you will always search for how many processors it is currently having, right? Means if there are more number of processors, then each processor can take a different process and it can execute this process simultaneously for efficient working, for faster running. That is the actual use of multiprocessing, right? So anybody having any question in multiprocessing, multitasking, multithreading, these three are the terms that will be asked in examination also, and maybe under a point of view also, they may ask you these questions. Anybody having any question in these three terms? Multiprocessing, multithreading, multitasking. Okay. Okay, fine. Then I will show you how do we implement this in our editors. How do we implement threads in our programs? Okay, first thing, okay, good, yes. First thing, thread itself is a class in Java. Okay, if you remember in your exception handling also, you might have read this message in exception. The message that I want to convey is your main itself is one thread over here in your Java. Okay, yes, this is example. Okay, it is divided by zero exception. Right. If I run this program, then it is going to show the message that there is arithmetic exception occurring, divide by zero, you are not catching it, JVM is catching it. Okay, that we have done. Now it is showing you that if we read out the message exception in thread main, this is the name of the exception. Now, what does this mean? That your this main function itself is one thread. Okay, and it is capable of executing, it is capable of creating, it is capable of calling different threads also. Every single process here in Java, if you have one single program, it can have multiple threads. We are going to see how do we create threads over here, but your simple function main itself is one thread that is currently executing. Okay, we are also going to see how to print the different current states. I have shown this states. All these states also can be printed over here, that currently the thread is residing under which state, whether it is sleeping, is it running, or whether it is starting, is it being born, or is it currently dead. You can see it. We are going to see these states also. They can be seen over here. These are predefined variables only. Okay, they have given these variables only in Java, and you can print this value whenever you want to do, whenever you want to see the current state of the thread. Okay, that you can do here. But again, your main itself is one thread which is capable of calling different threads. If you want to, I'll just give you one simple example. If you have an array of 500 elements, or maybe 1000 elements, or any number of elements, and you want to do some operation on this element, on this array, like say for example you want to simply multiply this all these values by, say for example, 10, then it is not possible. It is definitely possible for the mean. Okay, you can create one loop, you can initialize the array, and you can multiply all the elements by 10, and then you can print it. It is possible. But again, the process will be done by single thread main, which may take a good amount of time. If the array size is small, it is okay. If the array size is bigger, it may take a fair amount of time, which we don't want to happen. We want the program to execute in a short time. Then we will create different threads. Say for example, I create here 10 different threads, and each of the thread I am giving 50 numbers to it. And each thread on its own multiplies these numbers by 10. Then all the threads can execute simultaneously. In programming, you can make this thread start or run or execute simultaneously, which is going to ease up your task, which is going to divide this complete process into different execution, and it is going to consume parallel time. They have a parallel execution. It is going to take less number of time as compared to what you are doing with your single thread main. Are you getting the actual use of a thread here? The actual use of thread is to divide the process in such a way that you can reduce or save the time complexity over here. You can reduce the total execution time here when you create multiple threads. Just imagine if you are doing this sorting, okay, or if you are doing searching, these operations they require usually log and n log n time, or sometimes n square time also in sorting. The bubble sort it requires also n square time. Imagine if you can divide up your process in different threads. That one thread is simply using computing the, or maybe alternate elements are checked by threads, or in searching also maybe half of the array is searched by another thread and half by another thread. Then each of the thread can have its own individual processing time, but they are working parallelly, so that is not going to hinder your process. It is not going to take more time as compared to the sequential execution. So that is the reason we use here multi-threading. The actual use of multi-threading is to create threads. Thread is nothing but, in simple definition terms, you can say that what is a thread? Thread is nothing but a lightweight process, lightweight sub process, okay, which is going to reduce the final running time of the program. And also, it is the independent unit of the program. It is not dependent on another resources, not dependent on another thread actually. It is independent unit of the program that is having its own execution path. It is not going to come in another execution path. It is executing on its own. If I give 10 elements to one of the thread, it is going to sort on its own. It is not going to request the resource from another thread. It is having its own path of execution. And in Java, at least one thread is always there. Your main itself is one thread, right? So do you have any questions so far? What do you mean by thread? Then what is the exact definition that you will have to write in examination? Okay, I'm telling that also. This words you need to put in examination for getting marks, of course. That what is a thread? It is nothing but a lightweight sub-process, which is the smallest independent unit of the program, and it always has its own separate path of execution. And in Java, a thread is created by the thread class, where it is already there in this package, in the lang package. If we search here lang.thread, see, you can get here thread. It is always there in lang package. You need not to import the lang package. That is the reason even main is always a thread, because we don't have to import it. No, it is automatically accessible, and thread is kept in the lang package for that reason only, that you can create threads. However number of threads you want, you can create in your program. Okay, anybody having any questions so far? Okay. Okay, then I'll show you the sequential execution of the program, and then we can see how to use threads over here. Okay. Okay, good. Let me create. Okay, I'm just creating two different classes. Okay, I'm creating a class B, and both these classes are having one method, void show, or maybe print. Just print the numbers. Okay, we are simply using this function to print the numbers. That's all this is doing. Okay, I'm starting it with 0. I'm running it till 5, and I'm incrementing by 1, and I'm simply printing the value of 5. It is doing simply this much. This class is having only one function. It is printing the values of I from 0 to 4. That is all it is doing. I'm doing the same function here also. Okay, I'm using the same function here also. But say for example, I'm starting this with 5, and I'm running this till 10, and it is printing the value of variable I. Okay. Now to access these functions in our main thread, in our main function, in our main PS public static void main, they are going to create the object of both the classes. Okay, I'm creating the object of a first class A, okay, and I'm creating the object of second class B. Simple. I'm simply calling these functions. Okay, ob.print, and I'm calling ob.print. Okay. Now this is going to have a sequential execution. Okay, let us see. Yes, it is having a sequential execution. It is printing. What happened to, okay, ob.ob2 should come over here. Wait, yes, okay. See, it is having sequential execution. It is currently printing both the it is printing, it is finishing A first, and then it is coming to B. If I want to print all these numbers at the same time. I don't want to print, I don't want OB to execute to first and then the control is going to OB2. I don't want this to execute a sequence in sequential manner, but I want this to execute in a parallel manner. So for that purpose, I have to use a thread. But before I show you that, I want to show you one more thing. I told the sleep method, and I told you that this main function itself is one thread over here. To call the sleep function or to pause the execution for some time in this for loop, I can use the method, static method it is there, thread.sleep. Sleep is a function which allows your thread to sleep or go for that power nap for that much milliseconds that you pass here. If I pass here 1000 milliseconds, no, then the thread is going to go ideal for 1 second, right? Because 1000 milliseconds is nothing but 1 second. But one more thing, and this sleep is throwing some exception. Which exception? Interrupted exception. Why it is throwing that? Because at the same time, maybe some another thread is executing or maybe using this resource. Maybe you are calling it before it is, finish the sleeping part. Then it can call interrupted exception. So I'm simply keeping this statement in try and catch. No harm in that. I am simply catching the exception over here. I'm getting the superclass itself here. No need to worry about the subclasses. Okay. I'm calling the exception class here. Okay. And I am doing nothing over here. I am doing nothing in the catch. That is okay. You can leave the catch empty, of course. And at the same time, I am also repeating the same statements here also. I am simply pausing this thread execution also for some time. Okay. Then I am applying the sleep function here also. So before it is printing the rest of the statement, no, before continuing the loop, no, it is going to go for a nap for 1 second. Okay. Now let us run and check. You can pause the execution or you can make the thread sleep for 1 second by using this statement. See what is happening here. Do you get the use of the sleep method? It is not printing, it is printing sequentially. The call is going sequentially only. It is not executing both of them together right now because I haven't made this A class as a thread. But it is already a thread. A function itself is already a thread, which is not currently made a thread. I am not extending this class with thread, okay? I am not extending it with thread. It is one of the way of creating a thread is you have to extend the class with thread. Even though I haven't extended it with thread, I can call the sleep function because every time your main is calling something, no, thread is calling that. Main itself is a thread, no, your thread is calling this a function. Your thread is actually calling another thread itself. So it is by default a thread only. But however, to have the start of the thread, to have that runnable state, to have that run method, it is a different thing that we are going to see later on. But again, every single function that you are calling from your main thread, they will act as a thread only. And you can make this thread sleep by calling the sleep function, which is again causing the exception over here. So I'm surrounding the sleep statement by this try and catch. And I'm taking the thread is taking a nap for 1 second over here. So it is printing the elements after 1 second because I have made it sleep inside in the for loop itself, right? So it is taking a nap for 1000 seconds and then it is coming back here. So whenever this thread is going to sleep, automatically the sleep time, whenever it is over, again the processor is allocated to that thread. Again, the thread starts from sleep to run. It can automatically come from sleep to run as soon as the waiting time or the time given to that thread is over. It can automatically go to sleep to run state. And then it is running again, and then it is again going to sleeping. Again running, again sleeping. And at last it is going to terminate it. Are you getting this so far? Are you getting this much so far? What is the use of a sleep method? It is throwing some exception over there. You need to surround it by try and catch. And sleep causes the thread to pause for that much milliseconds. In the bracket, it is taking millisecond. For that much millisecond, it is pausing it. And then you can again resume the execution by it is calling the run method automatically for running the thread. In the backend, we don't have to worry about that. Okay. Are you getting so far? Is it clear in your mind?
Ma'am, but then what is the use of it?
What is the
Use of it?
Okay.
Why are we doing this?
Okay. Sleep is a function. See, whenever you are accessing a resource, we are going to see this in the deadlock and this communication of both the threads. Intercommunication of threads can happen. Intercommunication meaning whenever both the threads are accessing the same resource, you can tell one of the thread to sleep for some time until another thread is using that file. So while another is sleeping, no, one of the thread is using that file, and when it is coming back to run state again, it is the resource is free for you. Are you getting the use of sleep now?
Yes, ma'am.
Yes. Okay. Anybody having any question in how to write sleep method? It is a static method in the thread class. Thread is in the lang package. You need not to worry about the thread. Okay. Okay. Anybody having any questions so far? Okay. Okay, fine. Then I'm coming to one more point. Like I said before also, threads, okay, there are actually two ways of creating thread. First thing, before I am showing you how to create a thread, I am telling you there are two ways of creating a thread. And why there are two? Why can't only one work? That you will only tell me. See, the first way is by extending thread class. Okay. And second way is by implementing an interface known as runnable. Runnable is the interface, thread is the class. Either you can extend the thread class if you want, like exception only, no. If you want the class to throw exception, if you want the class to act like exception classes, then you will extend it with exception. Same way, if you want the thread to behave, if you want the class to behave as a thread, you will extend it with thread or you will implement it with runnable. Now, can you tell me why we have these two methods here? Why it is not simply extended by thread? Why do we need another method over here? There is no technical use over here. Why there is two methods? I'm not going into the use of both the implementations. No. Before that itself, you can tell me, because we have done this in abstract class and interface also. Why do we need implementing interface over here? Can you tell me?
Maybe we can use multiple threads by implementing runnable.
Okay. Yes. Again, good point. If you have a class, okay, if you have a class that is extending one class thread, okay, can this class extend another class?
No, ma'am.
Right, it cannot extend another class. No, at a time you can extend only one class. But if it is extending one another class, then can it implement also this runnable or not? That you tell me now, right?
Yes, ma'am. It can be done.
Yes. So there are two methods over here, because if you want to have inheritance using exchange relationship from one of the classes, no, then you can use implementing runnable, and you can again both the methods are same. The run method that you will be creating for making the thread run, it is the same in both the cases. It is there in runnable also, it is there in thread class also. But two methods are, because of that reason only, that you may want to apply multiple inheritance over here, which is not possible with multiple classes over here. So you will require here, this runnable interface. That is the reason we have two methods over here. Okay. Now we are going to see the first way of creating a thread. As I have told you, you can always extend this class, thread class. Okay. I am making the first class as a thread. I am also making the second class as thread. Then you will automatically feel that they both should be running in parallel, right? Thread means they both are threads, then they both should run in parallel. That should be the implication, that should be the output, right? Now, if I run this, if I let us see, are they running in parallel execution or not? See, the first one is executing currently. Okay, then the second one is starting. Again, they are not executed parallelly, right? The reason is that for the thread class, whenever you're extending a thread class, it is not an abstract class. Okay, keep in mind it is not an abstract class, because it is not asking you to override anything over here. Right? It is not an abstract class, the first thing. Second thing, this thread class is having the method run, which allows you to create threads. If I don't have this run method, no, then the thread implementation is still incomplete, because it is extending the thread. But the run method itself is creating thread inside its own body. It is making the sequential execution. It is making the task happening parallelly if you implement the or override the run method. Do we have the run method over here? No. Okay, then let us override the run method of the thread class. I am now writing here run. Is it the correct syntax? No. Why? See here, it should be public. Weaker access privileges, it should be public. It is not implementing run. Why? Because all the predefined methods in Java are always public. Now the overriding is possible. It is going to also show me that it is having override annotation over here, which you can implement. Okay. See, it is already having, right? It is already having the run method over here, which is already, you can override, you can add the annotation over here. Yes, you are overriding the run method correctly now. Okay. Now again, I'll do the same thing over here. I want this to be a thread. I'll make run over here. I'll make it public because I'm overriding. The syntax should be same. The signature of the method should be same. Done. Now you should think that it should be able to create through 2 threads and run properly. But do we have the print method now? No. We are renaming the print method with run. Again, if I am calling run method here, then you should feel that they both should run in parallel execution now. Because I'm calling the run method here, no, both should execute simultaneously. It should happen. Okay, let us run it and check it again. Is it running fine or not? I'm running it anyway. Okay, see, it is still having sequential execution. The reason is that the run method that you are calling over here, okay, the run method that you are calling over here, you are calling it explicitly. You are calling it, forcefully. No. To have this run method execute like a thread, we don't call the run method directly, but we call the start method. The start method in turn will call the run method, and that will make the thread execution properly. The run method, if you are calling here explicitly, it is not going to make a thread. To make a thread, we call the start method first. The start method in turn later on calls the run method after creating the thread of this OB object. Start method creates the thread of the OB object, means the thread is being born. Once the thread is born, it calls the run method internally. Start itself calls the run method internally, and then now both the threads are going to execute in a sequential manner. Okay, see now it is executing both of them. Are you seeing this or not? 3, 8, 9, 4, right? Some point of time you will also see this A, B, then it is calling B and A. It is 6 and 1. Why it is like that? You must have this question also. Why not always A and B? Even I have written both the statements like this. Why it is not A and B? Because whenever both the statements are called, what is the difference between the line of both, a calling sequence? Maybe just 1 or 2 milliseconds, right? What is the difference? What is the time in execution of both the threads? Just in milliseconds, right? It may happen that both the threads are reaching to the processor simultaneously that no, I want to print. Then if both the threads reach to the processor or the mechanism scheduler, at the same time, the scheduler picks a random thread that we don't know. The scheduler may pick a random thread and it can allocate the resource to it, and then it can print the function. It can call the run method automatically. Okay, that depends on the scheduler, how it is scheduling. One more thing to keep in mind, both the threads are currently having the same priority. Priority meaning the urge of running the thread. Do you have the highest urge of running the thread here? No. Both the threads, as I have not set any priority for any of the thread here, both of them are having the same priority. If both the threads are having the same priority, then which thread is going to the scheduler first? That is executed first. But again, it depends on the scheduler. If both the threads are going to the scheduler at the same time, no, then it may pick a random thread at any time. That depends on the scheduler, how it is scheduling, that we cannot know. Okay, sometimes the output may be randomized because of this, and every time you may not get the same output also here, okay? Because again, that depends on the platform on which you are running. See, right now it is executing A first and B second, then B first and this A second. But again, it depends on the scheduler, which we cannot predict. So in threads, dependent on the scheduler, everybody may get different outputs. That is okay. That is okay for us. Okay. Do you have anybody's having any questions so far? You look at the program, check it once. Do you have any question in the program? And just excuse me for 1 second. Just please check the program, okay? Yes, look at the code. If you're having any doubt, just let me know. How to create the thread using extends function. What is the use of run method? What is the use of start method? Start is allowing you to create the thread. Once the thread is created, then only it is allowed to go in the runnable state and then in the running state. Start is creating the thread, okay? Once the thread is created, then only it can run. If you explicitly call the run method, it is not going to create the thread because start is creating the thread first and then it is calling the run method on its own. We need not to call it. Okay. Are anybody having any questions so far? Okay. No questions. Are you sure how to create a thread? Two methods of thread, why they are there? What is the use of run method, the use of start method? Then the scheduler may pick any one thread that we are not sure. If it is randomized over there. Whenever both the threads are going for the execution at the same time, the scheduler may pick whatever thread that has came first for sure. But if they both come in the same time for execution, then it may pick randomly that we are not sure. So the output will be always unpredicted over here, and that is okay. That depends on the platform again. That is okay. Anybody is having any question? Okay. Okay, fine. Then we don't want to do the second method today. Okay, good. Then the second method we are going to see later on, not today. We are done for the session today. If you have questions, you can ask me. Otherwise, I will take the attendance and then you all can leave. The second method we are going to see it in the next slot, not today. I don't want to rush things. That is okay. Just digest this much. That is okay. I'll take the attendance and then you can leave. Ayush, Rohan, Vipin.
Present, ma'am.
Yes, Manav, Anuj,
Yes, ma'am.
Riddhi.
Present, ma'am.
Riddhi is there. Yashraj, Dash,
Yes, ma'am.
Mansi,
Yes, ma'am.
Nikita, Manthan,
Present, ma'am.
Smith Kumar, Devansh,
Present, ma'am.
Pala,
Yes, madam.
Yashang,
Yes, ma'am.
Dipen,
Yes, ma'am.
Tushar, Yash,
Present.
Darshan Maniar,
Present, ma'am.
Parmar,
Present, ma'am.
Uberaj, Rishabh, Ivanchi,
Present, ma'am.
Anuchali, Harshvardhan,
Present, ma'am.
Janvi,
Present, ma'am.
Vijayaraj, Radhanya,
Present, ma'am.
Bharti,
Present, ma'am.
Avinash,
Present, ma'am.
Limbani,
Present, ma'am.
Arjun,
Yes, ma'am.
Maharana, Tanmay Raj,
Yes, ma'am.
Dinesh Prasad,
Present, ma'am.
Anjwani, Sushil Prasad,
Present, ma'am.
Dhruvi,
Yes, ma'am.
Naitik, Harmik, Mohammed.
Present, ma'am. Dharmik.
Yes, yes. Harmik, you were there. Okay. Runal,
Present, ma'am.
Nidhi, is there. Arpit,
Present, ma'am.
Meghna,
Yes, ma'am.
Yash,
Present.
Savdeep, Divya,
Yes, ma'am.
Saifali,
Yes, ma'am.
okay. Samir Alam.
Present, ma'am.
Yes, who is there? Saifali. Nisha,
Present, ma'am.
Vibhusha,
Present, ma'am.
Parik, Aditya, Kriplani, Aditya Jain,
Present, ma'am.
Vedakan, Priyank, Tushar, Nikita, Girish, Pathik.
Present, ma'am.
Yes, Pathik.
Yes, ma'am.
Enrollment number 62. He is present.
Yes, ma'am.
Yes, 61, 59, 60, 63, 64 Pima, 65. Pima is there, yes. 65, yes. 73,
Yes, ma'am.
Mohammed, 67,
Present, ma'am.
Jaideep. Smriti is there, right? Smriti is not there. Vaishali,
Yes, ma'am.
Vasu,
Present, ma'am.
Kunal,
Yes, ma'am.
Hollywood. Then you all can leave the session.